Edexcel higher tier paper. This is a predicted paper for 2024. So while I go through this paper, I do recommend that you pause when you see the question and try the question out for yourself, and then unpause it so that you can see the solutions and we can go through it together. If you want this paper, it will be linked in the comments below or it will be in the bio. And as well, if you want to get some other exam boards or you want to see the foundation tier, all of the papers will be available on that shop. So let's start. So question 1. Express the recurring decimal 0.50, and this is recurring, this dot on top of a number. This is what it just means that it's recurring, so that means this would actually be 50, 50, 50, and this would just go on forever. So we want to express this as a fraction. So what we do is that we make x 0.750. This of course will go on. So now because there's two recurring numbers that go over, I'm going to times this by 100. So this means it will be 100x, because whatever you times, if you times this means that you have to times the other side, and this will be 75.050505. Now what we're going to do is we're going to substitute it from each other. So let's do this part of the equal sign first. So 100x minus x, that is 99x. And then if you do 75.055 minus 0.75, you will get 743.3. So now we'll just put the x, basically just put it to the other side. So now because we have this this decimal over here, what we're going to do is, so that we can remove this decimal, we're just going to times everything by 100. So we don't want any decimals anymore, we just want the whole fraction. So it'll be 990x and 743. So what we do is just put this to the other side, because we're multiplying here, the other way it will be divided, so it'll be over 990. And the answer, and since we cannot simplify this any further, that is the answer. Question 2. Simplify 5 to the power of 4 times 5 to the power of 6. So these are the laws of indices. So what we do is that, because even though these are times, what this means is that you see something, whatever the base, as long as it's the same, basically the same as just adding the bases together. So if you see over here, you just see we just do 4 plus 6, which is 10, so it's just 5 over 10. Now with division, it is the same, but instead of adding, what we do is that we just subtract them from each other. So here it will be just 5 times minus 2, so we know that it's 3, and then we just keep the base the same, so it's 7 and 3. Question 3. Write these numbers in order of size and start with the smallest number. So this is what comes with standard form. So what we're going to do in the beginning, we are going to try and have it so that we can understand every single part. So I think we just will start with writing it all in its full term, so we rule out the standard form. So if we just put 5, what we do is that we just, this would go 1, 2, 3, 4, 5. So there, that's now we're doing decimal spot. So that's 340. See over here, it is minus 5. So wherever the spot, like whatever the decimal is, if it's minus, you go back by however how much number is on the top. If it's positive, you go the other way. So if you do that, we see that this is 0.00034. This one is minus 0.00034. This one will be 34,000. This is 33,400. So now we can see more easily which one's smallest and which one's the largest. However, when we do actually write it in order, make sure that you always write it in order in its original format. So we can see over here, if we see the smallest, we can see this is the smallest. So we'll start with this. We can see the second smallest is this one over here, so put that next. And then we can see it is this. 0.0034 times 10 to the power of 5. And then it's 34 times 10 to the power of 2. And then 3.4 times 10 to the power of 4. This is smallest to largest. Sabrina has 250 grams of butter, 300 of caster sugar, 600 of flour, and 60 of cocoa. So work out the greatest number of chocolate biscuits that Sabrina can make, and you must show your working out. So we know that it can make 16 chocolate biscuits. So let's start this in the beginning by seeing how much max we can use from each one. So from butter we just do 250 divided by 100, we know that's 2.5. So it can make 2.5 batches. Now let's see how much it can make of caster sugar. So if we do 300 divided by 50, that is 6. We can make 6 batches. So if we see 600 over 120, that is 5. It can make 5 batches. And if we do 60 over 15, it is 4. So it's 4. So if we see which one now is the smallest amount of these ones, that's how many times we can use it, because these always have to be the same. You can't start, even though your butter ran out, you can't start making just cookies with sugar, flour, cocoa. You always need butter. So it seems like we can just make 2.5 batches of 16 biscuits per batch. So if we just now do 16 times 2.5, we see that the answer is 40. So 40 is the most amount of cookies that Sabrina can make based on the fact that she's using the correct measurements and every single ingredient that she needs. So 5a, simplify 2e plus 3f minus e 4 of f. So what we do is that we are going to separate each one. We need to collect like terms alike. So 2e and minus e will be together since they have the same letter. And we'll have 3 plus 3f and plus 4f together. So if we do 2e, so it's 2e minus e. We know that's just e, so let's put that here. And then now we have to do f, the f, so it's plus 3f plus 4f, that is 7f. So it's plus 7f. Now, expand 5 2c plus 3d. So with timesing, you can just do it. So we're only going to focus on the big number. So when you expand, make sure you have to expand it to each different one. So you do 5 times 2c and you also do 5 times 3d. So 10c plus 15d. Here are two straight lines, A, B, C, D, and P, Q. In the diagram, all the lengths are in centimeters. So AE, so over here, is the same as P2 times PQ. So this times 2 is the same as that. So find an expression in terms of x for the length of DE and give your answer the simplest form. So we are trying to find out this length over here. So they already gave us this expression, so let's just write it in. And what we're going to do, we're going to say DE is 1. So if we go, we'll do, so AE is the same as x plus 3 plus 2x plus y. So I'm just adding every single one of this so that it can equal. And that's the same as 2 times PQ, so it's 2 times 3x minus 2. Now we're just going to try and simplify as much as possible. So we'll get all of the x's together, so that's the same as 4x. There is only 3 plus y. And then now we're going to try and expand this, so it will be 6x minus 4. And now let's put everything onto the side. So we want y to be the subject, as that is our length of DE. So let's put every other thing to the other side so we can get that expression. So if we put this to the other side, this is a plus here, so it'll be a minus there. So 6x minus 4x, that is 2x. And if we put 3 to the other side, this is a positive here, so it'll be minus. So minus 4 minus 3 is minus 7. And that's the answer. So this is DE in terms of x. Okay, so question number 6. You can use this conversion graph to change between miles and kilometers. So we have miles on the y-axis and kilometers in the x-axis. Mary has to drive from Paris to Calais, then from Dover to Sheffield, and the total distance she drives is 350 miles. Mary has already driven 240 kilometers from Paris to the ferry she goes on the ferry to Dover, and then now she has to drive Dover to Sheffield. So Mary has enough petrol to drive 180 miles. Will Mary have to stop for petrol on the way to Sheffield? So if you see over here, the total distance she has to drive is 350, and she only has petrol to drive for 180. So will Mary have to stop for petrol on the way to Sheffield? So now we're going to see how much 350 is in kilometers. So if we see, let's start with something that is easy so we can see what the conversion is from miles to kilometers. So if we go over here, we can just see what 5 is. So if we go here, we can see that 5 miles is the same as 8 kilometers. So if we do 8 divided by 5, it is 1.6. So 1 mile is the same as 1.6 kilometers. So if we change all of this into kilometers, so that makes it easier for us, we can do 350, and we times that by 1.6, and we convert that into kilometers, so that's 160 kilometers, and 180 times by 1.6 is 288 kilometers. So she has already driven 240, so let's minus that away so that we don't include that anymore. So 560 minus 240 is 320. So what she has left is 320 kilometers left. And then she takes the ferry to Dover, and then she has to now drive Dover to Sheffield. So if you can see over here, she only has enough for 288 kilometers. That means that she will have to stop for gas, because after 288 kilometers she doesn't have enough gas, and she would need, if we do 320 minus 288, she has 32 kilometers that she needs to go in order, like, so that she can go to Sheffield and she can go all the way, but she's not able to do that unless she has the petrol and she stops for petrol. So it's yes, and you need to make this very clearly, because this is a question that they want you to answer. You will get marked on making sure you know how to explain, so you can explain by saying that that 320 is more than 288, meaning that she has to stop somehow because she won't be able to cover the whole distance. Question 7. Write 5 minus cert 5 squared in the form of a plus b and cert 5. So how we do this is that we do 5, let's just expand it out so that we can make it more easier on ourselves. So we do this the same way that we do a quadratic, in the terms that we times each term with each other. So this is the terms that we have to do. So we do 5 times 5, we know that that's 25. And when you times a surd with just a normal number, what it turns out to be is just, it'll be 5 to 5 like that. It's going to be times like this. But however, because there is a minus, we minus 5 surd 5. This is the same over here, it would just be minus 5 surd 5. However, when you times two surds together, what happens is that you just cancel the surd out, so it would just be n right here. So if you do minus 5 times minus 5, the answer would just be plus 5. Plus, because a minus and a minus goes together to be a plus. So it should be plus 5 at the end. So now all we have to do is that we collect like terms, 25 and 25, and we do these together. So that just ends up being 30. And if you do minus 5, because it's not timesing anymore, all we do is that we just take the outside, and we keep this like base in the sense that surd is kind of like an x, we kind of just leave it alone, and it'll just be minus 10, 5. convert this back into mixed form. So that 3 in the beginning that is over here just means that this is 3 like full of 3 over 3, and then you had 1 over 3 left. So what we can do, how we just put it back into mixed form, you just do this, you do the whole number times the denominator, and then that, and then you just add that to the numerator. So if you do that over here, it would just be 3 times 3, which is 9, and you add it to this, so then it'll be 10, and it will just stay over the same denominator. Now if we do that to the same one over here, we do 4 times 5, which is 20, and you do plus 2, so it's 22 over 5. Now when you times, all you do with timesing is that you just times the top together, and you times the bottom together. And that's all you have to do, it's as simple as that. So 10 times 22, that is 220. And if you do 3 times 5, that is 15. What we're going to do now, because we can simplify this, we're going to try and simplify it so that we can make it easier for us. What we can do is we can divide by 5 on both sides. So if you do 220 divided by 5, we know that that is 44. And if you divide by 15 by 5, it is 3. And then from there, we can now put it back into a mixed number because that's how they want it. So if you go over here, what we do 44 divided by 3. This is 14. However, there is a remainder of 2. So we just kind of put it back into this format. So we do 14, and whatever remainder you have left, you put it back into the fraction with 3 as the denominator, and that is the answer. 8. Kim invested $2,000 for 2 years, and by the end of the first year, the value of the investment was 15% more than its value at the beginning of the year. And by the end of the second year, the value of the investment was 10% more than the value at the end of the first year. So work out the value of investment at the end of the second year. So we have 2,000, it starts with 2,000, and this is the beginning of the year. So the value of investment was 15% more at the end. So what we do is that you just times it by 1.15. This 0.15 represents 15%, and because they want more, you just add the 1 because that 1 is kind of as 100%, which is the original price. So at the end, it's 2,300. You could also do this by finding 15% and just adding it. It's whatever just works for you. So we know that this is the end. So then it says at the end, by the end of the second year, the value of the investment was 10% more than its value at the end of the first year. So what we do, we have to use this value now. We do not use this anymore because it doesn't refer to it, it refers to the end of the year. So we just do by 10% more. So we know 10% more is just, if it's just 230. 230 is 10% of 230. So what you do is just kind of move away a 0, and that's how you figure it out. You could have also just times it by 1.1. So we just need to add this now. So we do 3,000 plus 230. You know that that is 2,530. And that is the value at the end of the second year. 10. The points A to 6, 1 and B minus 2, 5 are in line with the equation y minus 1 over 2x plus 4, and M is the midpoint of A and B. So find the equation of the line through NP is perpendicular to y equals minus 1 over 2x plus 4. So if you just draw this out, so if you do, it will be 6, 1, then it will be B5. So kind of just so it looks kind of something like this. They want the midpoints, which is over here, and they want this line that is over here. They want to know what the equation of this line. So first what we can do is that we can find the gradient of this line. And a gradient for a perpendicular is the reciprocal of the line, the original line. So what we do is just we do minus 1 over 2. We just switch the sign. So if it's minus, it becomes a positive now. If it was a positive, it turns into minus. And what we do with that would just turn it upside down. So we do 2 over 1. So now we know that the gradient of the perpendicular is 2. And if it was parallel, parallel is the same gradient. So we know if you see a line and equation, it's mx plus c. So we know what the value of m now, because m is what gradient is. We know that it is 2. Now we have to find what the coordinate of this is, and how you find that is you basically just do the halfway point between these two ones. So what we do, we are going to do 6 plus minus 2, and we just divide that by 2. Kind of just finding it as a normal one, so that would just be 4 divided by 2. We know that this is 2. Now if we do the same for y, we do y 1 plus 5, and we just divide by 2, and we know that that is 3. So it's 2, 3. That is the midpoint. So because we already know what one point of the line is, we can just substitute that into y and x, and that's how we're going to find out our c. So we do 3, 2, and we know x is 2 plus c, and then we do 3 plus 4 plus c. Turn it on the other way. If this goes to the other way, it's going to be minus 4. So minus 1 is c. Now we put this back into the original equation, which is y to x minus 1. And that is the answer, and that is the perpendicular line equation. The table below shows information about heights of 60 students, and on the opposite grid, draw a cumulative frequency graph for the information in the table. So the first thing you do when you see that you need to draw a cumulative frequency graph is start adding these, because you don't just plot them in a way, because it's cumulative, meaning that 4 is the same as you need to keep adding it. So this actually includes these things over here. So you need to start adding. So we know that this is 4. The first starts with 4. If we do 4 and 5, we add them together, it's 9. And then if we do 4 and 6, you know that this, we do 9 plus 16 is 25. Do 25 plus 27 is 52. 52 plus 5, 57, and 57 plus 3 is 60. So these are actually the graph that we're going to plot. And because this is a cumulative frequency graph, we use the upper bound of each one so that we can plot the graph. So the x values are always going to be this over here. It will be the 150. It will be the upper bound of each modal class. And then this over here will be the y. So if we just go over, so you see you do 160 and 9. Go over here, it will be 160 and 9. Get over here. So make sure you plot these as accurate as possible, so that the curve that you draw is really smooth and is what the examiners are looking for. So 170 and 25. If they're asking for you to actually draw the scale as well, make sure that the scale cover at least half of the graph, or else it won't be counted and be counted as too small. So make sure the scale are big enough that it can actually include every single one, and it actually takes up at least half of the graph that they gave you. 190.57. After you got and you plotted all your graph, what you're going to do is you need to always start at 0, and you free-handedly, you draw a curve, which indicates your cumulative frequency. Make sure you do not plot it straight, like from line to line. You kind of just like straight lines. That is considered incorrect, and you're not going to get any points for that. It needs to be so that it's a curve, and it needs to be freehand, so that you did it just with your hand on ruler. So find the estimate of the median. So how you find the median is that you go to your cumulative frequency. We know that we have 60 overall, and half of 60 is 30. So what you do is that you go from 30, you go down, see where it ends, touches your curve, and you stop there, and then you start going down. You can see that that is range. This is the upper quartile minus the lower quartile range. So what upper quartile is, it's 75% of your cumulative frequency, and lower is 25%. So because we know it's 60, we know 45 is upper, and we know 15 is lower. We go in, we can see 45, we keep, and then until we touch the curve, and then we go back down. You can see over here, this is around 177, so let's put that down, 177. We see the lower quartile range, we know that that's 15, so it's over here. We keep going until we touch the curve, and then we go down, that's 165. Make sure that you always keep your lines, you're drawing, you're working out lines, because that is part of your working out, so the examiner knows, in case, even though with these type of questions there is no set, they'll be like, the answer is 170 plus or minus 2. Even if you do get pretty far off, they're going to see it based on your graph, so make sure that you keep these lines so that they know how you're trying to work this out, so that you can get opportunities for those marks. So 165, it's 165. Now all we have to do is just minus from each other, and we know that's 12 centimeters. 12. In a supermarket, the probability that John buys a fruit is 0.7. And in the same supermarket, the probability that John independently buys vegetables is 0.4. Work out the probability that John buys fruits, or buys vegetable, or buy both. So what they're asking for is the probability John buys fruit, buys vegetable, or buys both. The only thing they are not asking for is if it buys none of those things. So that's what we're going to focus on, and then from that we'll just minus it from 1, so that means that we know that that is the other side is the probability that will get all of these. So what we do is what is the probability that he does not buy fruit? This would just be 1 minus 0.7, so this is 0.3. What's the probability he does not buy a vegetable? It's 1 minus 0.4, and this is 0.6. So we just times these together. So this is the probability that he does not buy any of these things, and this is 0.28. This is 0.18. This is the probability he does not buy anything. So what we do is that we just do 1 minus 0.18, which is 0.82. So this therefore means this is the probability that he buys something. So this would be a fruit, vegetable, or even both. A publisher checks a document for errors and records the number of documents are checked every day. He also records the total number of errors in documents each day, and he uses a scatter graph to show this information. So here's the total number of errors, this is the number of documents checked. On another day, 90 documents are checked, and there's a total of 17 errors. So show this information on the scatter diagram. So we just have to put it into it. So we see 90 are checked. So over here is 90. So we'll be following that, and there's 17 errors. So if we just go over this key, over here would be the half of 20 and 15, so that's 17.5. So let's say just around here. So we just go up somewhere here, somewhere here. So this is the point. Since all of them are x, we're going to put an x there as well. Describe the correlation between the number of documents checked and the total number of errors. Here they're looking for, so if you just see all the x's kind of go in a straight line, this is a positive correlation. If you see that all of them kind of goes down, this is a negative. So how do you know if it's weak or positive, or weak or strong? Just how straight that line is. So if you see over here, you can see that there is a general trend that it is going up. However, this trend isn't very strong, since there is some anomalies here and there which are over there. But what we're going to write is that it goes up, so therefore it is positive. One day, 110 documents are checked. Estimate the total number of errors in this document. So what we do is that we draw a line of best fit. So this blue over here is my line of best fit. This is where I try to go through as many of these crosses as possible and try to make it so that there is the same amount of crosses on each side and the same amount of distance. So now what we do is that we go to 110, which is over here. We draw a line, we draw until we touch this line over here, our line of best fit, and then we go to the other side, and you can see over here it's around 18, so there is going to be around 18 document check, and this will just be specific on what type of line of best fit that you draw. But try and make sure that it goes through as much as possible and it kind of goes with the trend. Solve 4 times 8x minus 2, and this is over 3x equals 10. So first what we are going to do is we're going to move the 3x to the other side. We try to get rid of fraction as soon as possible because they're always just such a hassle. So because it is division on one side, we just put it on the other side, so that means it just times. So 3x times 10 is just 30x. Now we want to expand this bracket, so it would be 32x minus 8 equals 30x. Now we're going to put this to the other side and this over here to the other side. Remember that when you switch sides, it's the positive and negative sign also switches to each other. So here it will be 32x minus 30x, so that's 2x, and the minus 8 will just be a positive 8, so x. Now we're just going to divide it, so x is 8 over 2, x equals 4. Write as a single fraction in the simplest form. So that we can have it into a single fraction, this is kind of like a normal type of fraction situation. What we do is that we always try to make the denominator the exact same, and what we do is just we times it by each other so that we can get the lowest common multiple, and the easiest way is just times it for each other. So we're going to times this by this, so y minus 6, and we're going to times this by y plus 3. So it will just be y plus 3, y minus 6, minus, again, y plus 3, y minus 6, and that's multiplying with each other. So now we'll just multiply this with this, so it will be 2y minus 6, and this by this, which would just be y plus 3. Now, because we're going to minus it from each other, the denominator will stay the same, so it will be y plus 3, y minus 6. And then we'll do 2y minus 6. Now because there's this negative over here, we do need to make sure that we times it. This is a common mistake that most students do. So it'll be minus y minus 3. Because we need to times it with this before we actually can add it to this. So it'll be minus y minus 3. So now let's expand it out. We can expand the top part. We do not need to expand this anymore. This is kind of as simplified as it can be, so we can just directly put that into our answer. If we expand this, this will be 2y minus 12 minus y minus 3. Now we just take all the y's together and all the normal numbers together, so it will be 2y minus y is just y, minus 12 minus 3 is just minus 15. And that is the answer. 15. ABCD is a regular pentagon, and BCF and EDF are straight lines. This to this straight line, and here to here straight line. Work out the angle of CFD. So CFD just means the middle one over here. We're trying to find that angle. So this is the angle we're trying to find. This is x. So show how you got your answer. So what we start by doing is that we try and find what the angle is in a pentagon, and we can use this using just a simple equation, which is n minus 2, which n means the side of whatever shape that you have, the number of sides, and you times this by 180. So we can see a pentagon here, so we're just going to do ABCD has 5. 5 minus 2 times 180, we know that that is 540. So because this is a regular pentagon, this means that all angles are the exact same. So what we could do is we could just divide it by 5. This means that it will be 108. So each one of these are 108, because we know that this is a regular, it's not irregular, so all the angles are the same. So we know that EDF are straight lines and BCF is straight lines. We know that in a straight line equals 180. All the angles in the line equals 180. So we know that these are also, we could just do 180 minus 108, and we know that this is 72. And this is the same over here. So now we know in a triangle, find all the angles equals 180. We can also use this to figure it out. So we just do 3 minus 2 times 180, and that also equals 180. So I just recommend you memorize it. So what we do is we just do 72 plus 72 minus plus x, which is what we're trying to find, equals 180. So if you just move these to the other side and just minus x equals 180 minus 72 minus 72, we know that the answer is 36. 16. OAB is the triangle and N is the midpoint of OA over here, and N is the midpoint of OB. So OM, so this to this is M, which is shown over here, and ON is N. So show that AB is parallel to MN. AB, this is parallel to this over here. We are going to start by finding what MN is in terms of the vectors. So we know that it's MN. So if we go from here to here, we can see that we go this way, which is the opposite way. So it's minus M. And over here, which is plus N, because we're going that way. Just trying to find different roots. So it's just N minus M. M. Now we are going to find what AB is, which is over here. So if we know that O to M and this is a midpoint, we know that N to A would also be M, and we know N to B will also be N because they are the same distance, because midpoint just means half, exactly half. So if we just find what A to B is, so we want to go this way, we'll do this in green. We want to go this way. We basically, another way to go that way is to go from A to O and to go from O to B. So we're going to do minus M again. So this 2 minus M is minus 2M. And then we have plus 2N's, so that's plus 2N. So we do 2N minus 2M. So we can see over here that we can factorize this 2 out. So we'll do AB, that equals 2N minus M. And what we know, because it is parallel, we know that there should just be a scale factor in the set, where when in a graph it is parallel, they have the same gradient, they have the same scale factor, it's the exact same overall equation is the exact same, it's just the scale factor is different. We can say that therefore AB is the same as 2MN, because this is the scale factor as you can see over here, and that is our proof, so because it is a multiple. So make sure you, because they are asking and it's a show that question, you really at the end you write your conclusion down to say why you came to that conclusion. 17. The diagram shows part of a curve of the equation y(f(x). So the coordinates show a minimum point of the curve, which is 3 minus 4, which is over here. Write down the coordinates of the minimum point of the curve with this equation. So plus 3. Because it is not part of the fx, we know that this is to do with the y coordinate. If it's not inside, like let's say these two, we only change the y coordinate, and with y coordinate it stays the same. The sign stays the same. So we'll just do 3. 3 would be the same since we don't change it. It's the x coordinate. Do minus 4 plus 3. This is minus 1. Now, with this one, it's different. The x is the number that we have to change is inside the x. So that means we just affect the x. So the y will stay the same, minus 4. It stays the x, and this means because it's in the x, it's the opposite sign. So over here, we are timesing it by x. This means that we just divide by x. So we do 3 divided by 2, so it is 1.5. Now with f minus x, we are just doing it inside. We are just changing and manipulating what x is. The y will stay the same. And with that, we just make it a negative, because since there's a negative. If it was already a negative number, we'll just make it a positive. So here it'll be minus 3. This is kind of the same. This means that the graph will just be that way now. It'll just be going over there. This is minus 3, minus 4. Here, plus 3 just means that it goes up plus 3 in y.
And over here, it just times 2, so that just means that it will go more like that. Eight, the diagram shows a floor plan of Mary Conservatory. So Mary is going to cover the floor with tiles, and tiles are sold in packs. One pack of tile will cover 2 meters squared, and a pack of tile normally costs 4.8. Mary gets a discount of 25% of cost of these tiles, and Mary has £100. Does Mary have enough money to buy all the tiles that she needs? Show all your working out. So as you can see that we need to answer a question at the end, so make sure you have a sentence at the end to completely answer and give your reasoning as to why, because 1 mark will always come for that sentence over here. So let's try. First thing that we need to do is we need to get the area, see how much area that she needs to cover. We can do this by splitting the shapes however you want. I think the simplest way right now to do is to split it so that it is a trapeze on top and it is a square at the bottom. So if you can see here, so for the square we just do 3 times 2.2, and that is 6.6. And then now we're going to do trapeze. How do you do area of a trapeze? This will be in your formula booklet, I'm pretty sure. And you just do its base plus height it is half base plus height. So if we label this, it will be A and B. So the area just half A plus B times by the height. So let's just input the numbers that we have in. So we have half, we have A and B, so this is the exact same as this over here. So it's 3 plus 1, that's B. And the height will just be 3.4 minus 2.2. That is times by 1.2. And the area would be is 2.4. Now what we do is that we just add both the area to see the overall area of her conservatory, which is 2.4 plus 6.6, which is 9. This is 9 meters squared. One pack of tiles over here covers 2. So we need, so if it's 9 over 2, 4.5 overall. But because that we need to cover every single tile and they don't offer 0.5, we would need 5 overall so that we can cover every single part. So always round up in these scenarios. You can't just have so that they cover 8 and then there's that 1 left over. They would need 5 to cover the whole thing. So 1 pack of tiles normally cost 4.8. So what we do now is we do 4.8 times by 5. 124 overall. Now she does get a discount of 25%, so we do times 0.75 because she'll only need to end up paying this 75%, and then that is 93. So she'll have to be paying 93. She only has 100. This means it's yes, she does have enough money, as it's only gonna cost her 93 pounds. Okay, so make A the subject of the formula. So we can see over here, we are going to start by moving all the fractions. It's not something that we like. That's the first thing I'll do. So because it's division here, we're going to put this to the other side. So it just times. So 4 minus A, that equals 3A plus 5. Now if you just expand the brackets, 4P minus PA equals 3A plus 5. Now we're going to put all the A's into one side and all the other numbers in the other side. So we'll move this over here and move that over there. So it'll be 4p minus 5. Remember, the signs changes when it crosses this equal sign. And it will be 3a plus pa. Now, so that we can only have one a, because to make a subject, we only want to have one of the subject that we want, we are going to just factorize it out because it is a common thing in both values. So 4p minus 5, we're going to put a outside the bracket. We'll do 3 plus p. Now, all we have to do is that we take this whole thing. So let's say in this term, we are kind of multiplying all of this by a. So when we put it to the other side, we will be dividing it. So it will be 4p minus 5 divided by 3 plus p, and that equals a. And that is the answer. 20. Reflect shape P in the line x minus. First thing we're going to do is draw this x minus 1 so that we can really know where we are going to draw the line from. So it is over here. This is the line x minus 1. So now all we have to do is reflect it. And this is just a game of just counting your numbers. So if you just see over here, let's start with this point over here. We do 1, it's 1, 2, 3 away from the reflection line. So on the other side, it should also be 3 away. So this is our first point. Now we're going to do this point. It is also 3 away. Therefore, it has to be 3 away over here. That point. Now we'll do this point. This is 1, 2, 3, 4, 5 away. So this has to be 5 away. 1, 2, 3, 4, 5. Put this point over here. Now with this one, it's 1, 2, 3, 4, 5. So 5 points away again. And all we have to do right now is just draw all the lines and put them all together. And that's the answer. It is as simple as that. And this is the reflection of P. ABD is a right angled triangle and all measurements are given in centimeters. C is point on BD such as CD is surd 3 over 3 and AD equals BD and that equals surd 2 over 2. Work out the exact area in centimeters squared of the shaded region. This over here is the region that we are trying to find the area of. So the first thing we are going to do is we're going to find the area of the whole triangle. So even though it doesn't show this on the diagram, if you did read the question carefully, we know that BD is surd 2 over 2. So what we do is we do surd 2 over 2 times by surd 2 over 2. And because this is a triangle, we will times it by 1 over 2 as well. So when we just times every single thing, times all the numerator together and all the denominator together. Surd times a surd just means that it is the number inside. So surd 2 times surd 2 is just 2, times by 1 is just 1, and 2 times 2 times 2, this is 8. So the overall area of the triangle is just 2 over 8. Now if we find this over here, we find triangle CAD now, we can just do 2 over 2 times 3 over 3, and we would times this, of course, by 1 over 2. So surd 2 over 3, 2, this is just going to be 6. The surd will stay the same because it's not timesing by each other. If you do 2 times 2 times 3, this is just by 12. So what you do is now you want to just minus them from each other, because if you minus this big by this over here, we would get the shaded region that we want. So we'll just do 2 over 8 minus 6 over 12. That is the answer. However, we can simplify this even just more. So we'll just do 1 over 4 minus 6, 12. And that over here is the answer. So now the last question. Solve the simultaneous equation 3x plus 4y equals 5 and 2x plus minus 3y is 9. So what we're going to do is we're going to try and make x the same number. So we want to make it 6x. So the first thing we are going to do is we're going to times all of this by 2 and times all of this by 3. Remember, if you're just timesing 1, you have to times every term in that whole equation. So if we do the first one, we times everything by 2. So plus 4y times 2 is just 8y, and that will 5 times 2 is 10. Then the next one will be 6x. So 3 times minus 3y is minus 9y, and 9 times 3 is 27. Now what we can do is just minus them from each other so that we can get rid of the x, and we only have one unknown. So 6x minus 6x is just 0. So we have 8 minus 9y. We know that this is minus 17y. So because it's 8 minus 9y. So 8y minus 9y, because there is that 2 negative now, that is going to become a positive. So it's 17y, and 10 minus 27, this is minus 17. Now we put it on the other side, do minus 17 over 17. You know that y is minus 1. Now what we have to do is put this back into the original. Always put, when you substitute back, we put it into the original so we make sure we get the correct x. We'll just put it back into the first equation. So we do 3x, 4, this is times minus y, because now we know what y is, equals 5. So that's 3x minus 4, 5, do 3x, put this to the other way, so that means the minus becomes a positive, so that's 9, put x, 9 over 3, x is 3. So just y is minus 1, and x is 3. So that is the end of the paper. Thank you very much for staying till the end. I hope this is helpful for you. Make sure that you do go also watch the GCSE one, even though it is a different paper. You can still learn from it, since math at the end of the day is math. If you want some other papers, or if you want this paper in specific or a foundation or higher, check out the shop. It is in the link below, and you can see all the different ones. Thank you very much, and let me know if you have any questions.